speakers, I don't remember his name, from IO will be actually coming out and sitting in on our little panel, probably talk a little bit. I know he does developer relations stuff on the Hangouts Meet, no, Hangouts chat, like the bots.
Yeah, for G Suite and stuff like that?
Yeah.
Yeah.
So that'll be pretty cool. I think his name's Wesley.
Yeah.
But yeah, so May 15th, that'll be at the Nerdery. We'll have that up on
Meetup soon.
Yep. And then.
Hi, I'm Dina Greenfield. I'm just here to introduce myself because I wasn't here at the last event that we had, but I'm kind of a new member of the team. I have my own instructional design company here in Chicago, and it's really exciting to see so many people who signed up actually show up. So thanks for coming to this, and hopefully more of you will join us organizing these events.
Yep.
Okay, so she skipped out on that. In April, on the 17th, we're having a women-focused event. We haven't really fully flushed out the organization on it. April 17th at 1871. Yes, men, you are invited. Don't worry. It'll be a lot of female speakers. Is kind of what we're aiming for. She's taking it from me because I'm going to do it.
No, I just wanted to say that I'm now the Women Tech Hackers liaison for Chicago.
Woo!
I'm excited to see some ladies here, and come talk to me afterwards. I hope we can do some events together.
Yeah.
Right.
Tell her what you want to see, and we'll try and make it happen. Maybe even for April.
Cool. Is that it? I think we got covered extended events. Yeah, let's get it started.
There'll be a form at the end. You could win stuff.
Yes, we are going to be having a survey at the end of this event too. So follow us on Twitter for great events. Follow us on Meetup for sure if you aren't already. So let's actually go ahead and get started. So this is going to be a link for Quick Labs. That's a long thing to type. That's a QR code you probably can't scan. We understand. So we put this all on Meetup for y'all. So if you just go to the Meetup page, there's a comment by me about a few minutes ago saying, hey, if you never use Quick Labs support, please sign up for Quick Labs. So let's give everyone about 5 or so minutes to just go through that process of creating an account, verifying your account. It's, again, a free account. And then from there, you can click this link, and it should give you a free month of Quick Labs. So we can do the labs today together. So let me actually get up the Wi-Fi slides here first. So does anyone need the Wi-Fi so I can actually go into the slides in the presentation? Just checking in. All right. If not, there it is. So let's just present this. Testing. Cool. 1, 2. Alrighty. So the slides are going to be shared. I'll put this link also as well on the Meetup page too. So basically, during this, you can use these slides to kind of help you out in what we're going to do today. But essentially, why are we here? Today, we're going to be setting up a development and production environments in the cloud using a tool called Quick Labs. We're going to be learning some introductory Docker. So if you haven't used Docker before, some pretty good stuff. And hopefully, if we can get really into it, we can do Kubernetes. It's all based on time. And also, you can do big data on your own time because, you get your own time from this, and we'll show how you can access that. So everyone here today, after you sign up and you click that link, you'll get essentially a month for free of Quick Labs. If you complete the GCP Essentials track, that we're going to do 3 of the 6 labs together, Google will actually give you another month for free of Quick Labs, which is going to be great. The nice thing about Quick Labs is it gives you these like reward badges. You can kind of put them on a resume, put them on, you can sew it around hey, I've completed courses from Kubernetes and GCP. So what is a study jam? Let's kind of just get started while people are signing up. We're going to be learning the fundamentals of Google Cloud and Google Cloud Platform. And we're going to learn how to run some containers on there. And as well, if we have time, talk about data engineering, some big data stuff on there too. How long does it take? Yeah, it's going to be about a 3-hour session. We'll have a break in the middle. So the way we structured it is about an hour and a half of kind of a lab at the start, and then we're going to have a break for about 15 to 20 minutes. Maybe if we need more time, we have 30 minutes, that's fine. And then we're going to wrap up with about an hour, hour and a half of like in-depth into Docker and stuff like that. And the end result is you'll get this badge, and on top of it, you also get Quick Labs access too, which is great. There's kind of the agenda. If you have photos, feel free to share with hashtag Google Cloud Study Jam too. And there's the fourth lab. The great thing is that there's no rush. You don't have to rush through all the lectures here today. You could take that home. That 1 month doesn't expire just like here, right? You can finish that on your own time. Or if you need more time to kind of go back and remaster some of those steps that maybe we kind of covered. Let's see. So again, to get started, make sure you sign up. There's going to be like an opt-in for sending me valuable promos. You can sign up for that. If you already are a Quick Labs user and you have used Quick Labs in the past, don't worry. You can actually just go to my account/profile. So I know some of you said that I already did Quick Labs before. Go to my account/profile and just check in marketing opt-in. The reason this is needed is how Google can send you the 1 additional month for GCP Essentials. That makes you eligible. There it is. Makes you eligible for another month for free. If you've already done these labs before, you can actually contact support@quicklabs.com, and they'll actually give you a credit so you can go ahead and retake them. So don't worry if you did them before, let's say a few months ago, and you really want to get back and master some of these topics. Support@quicklabs.com. Tell them that you were at the GDG Chicago meetup, and they should be able to square your way. If not, you can go ahead and CC me or ask me on Meetup, and I'll be happy to try and get that squared away for y'all. And any general questions on your own time where we're not here together, you can reach out to support@Quick Labs if like something doesn't work or you launched a lab and it didn't spin up. So we can do that. So before we get started, how's everyone doing on creating accounts? Anyone still kind of just checking in? Yay! This is awesome. This is great. Did everyone go ahead and click that link? Once you logged in, click the link in the Meetup message. Does anyone want me to blast it up in bigger text or something so everyone can see it? Let me just go ahead and do that. I'll put this up for about a minute or so, just to make sure everyone kind of sees it. Oh, if you scroll down, it's a comment. Yeah, you signed up before? Yeah, cool. So when you actually click that link, and thank you, this is an important step. If you go to that link, you'll see a enroll for this course or this quest. So go ahead and click that. That's actually how you get that credit. So. Yeah, for sure. Mm-hmm. It's also on the Meetup page if you guys just want to click the link. All right. Don't see any frustrated faces. Good. Assuming things are working. I'm going to go ahead and get started just for the sake of time. But if anyone has successfully done it and would like to help their neighbor out, that's really be helpful too. So if anyone, you see someone really frustrated, please make sure to help out because we're all here to learn together. So, so once you actually enroll in the course, you're going to be presented with a few labs, right? The first lab we're going to be doing is creating a virtual machine. For those not familiar with Google Cloud Platform, it allows you to essentially create infrastructure within the cloud. So very similarly, how you can create a physical server at your home and have that as being your running machine, you could do that all via software in the cloud. And this is kind of how you can get started creating a basic Linux Ubuntu box. So the 3 labs we're going to cover in the first quarter of this, first half of this, sorry, is going to be creating a virtual machine. From there, we're going to provision a service of the cloud launcher. And then from there, we're going to create a persistent disk. Essentially, so you have storage that's not ephemeral, so it doesn't go away when you destroy the VM. It's essentially like if you need something long-term, you want to store files, you want to create a new VM, and we'll kind of go through that as well. Alrighty, so with that being said, let's go ahead and get started. So if you're all at the screen, you can go ahead and creating a virtual machine. So just to kind of give a recap of I know many of you have maybe never used Quick Labs. The nice thing about Quick Labs is it provisions an account for you, a Google Cloud account for you, by hitting that Start Lab button. So make sure and there's a timer at the top. When that essentially is how long that account will live. So by hitting Start Lab, you'll have a timer. So make sure you click on it when you're ready to begin, and we're going to get started. On your left-hand side, if you don't have it, it may be hidden in this little bottom arrow over here. And you can click that, and but once you start the lab, your username and password and your project ID will be there, and a link to open it to get started. So let's get started with a self-paced lab here. So Google Compute Engine lets you create a virtual machine running different operating systems, including many flavors of Linux. So Debian, Ubuntu, SUSE, Red Hat, CoreOS. I personally like Fedora. That's me. And Windows Server too. We can't forget Windows as well. You can run thousands of virtual machines on the virtual CPU on CPUs. And in this hands-on lab, we're going to actually create a virtual machine. It's going to actually be an Nginx web server. So Nginx is if those are not familiar, a web server you can use to host static, in general, websites. And we're just going to get that up and running. It's very similar to Apache or IIS for those on the Windows side. You can copy and paste the commands. That's totally great. I learn a lot by typing, so I'm going to actually be typing the commands out to the best of my ability. If it's really long, we'll see how that goes. If you're not familiar with Vim, Emacs, or Nano, it'll be really helpful. If not, the guide actually kind of walks you through it. So what you need, we already have internet, so hopefully we're all good. To start your lab, you click on the top right. So let's go ahead and click Start Lab. And when you're here, you may actually have launch with your subscription if everything went well. I'm just going to check in. Does everyone see that? Everyone kind of went through the thing. If not, make sure you click the link and you're logged in and everything. It should say, on the left-hand side, it'll say launch with your subscription. So, yeah, your subscription, yeah. So that'll launch you. So I'm going to launch with my credits since I kind of went ahead and worked with Quick Labs, so I have to use credits for this. Okay. So as you can see for me, my timer started, and I'm going to go ahead and proceed here with a sign up. So we're going to open up the Google Cloud Console, and it's going to prompt you to log in. You're probably going to, if you use Gmail a lot and stuff, you're going to probably have a lot of these. So just click Use Another Account. Go ahead and copy the username. You can just click the little paste bin over here and actually copy it. And you can hit Next. And then make sure you copy the password. If you have autofill, it could, yeah, so. So when you first log in, I know many of you probably aren't here, you're going to get prompted with welcome to your new account. Again, as these are fresh accounts, they're going to be provisioned for you on every code lab. So you're just going to have to click accept, that you understand this is a Quick Labs thing. Just hit done on the protect your account. Again, they're short-lived accounts, so no need to worry about account security here or anything. Say no, I agree. So then you can like email me updates. Again, you're not going to have long-term access to the account, but you do have to agree to terms and service that you're using Google Cloud and its infrastructure. So go ahead and click accept. So right now you're kind of presented with your first intro view of what the Google Cloud Platform looks like. The nice thing is you can have a lot of like dashboards around like your API calls and how many requests are being made in. Right now it's not very exciting. There's nothing in here. But on the side you can see various things like App Engine, Kubernetes Engine, Bigtable, Data Store, SQL Spanner, etc. But to get started, let's just kind of go back and say, we're going to be using a lot today the Google Cloud Shell. So no need to have Docker locally installed. The great advantage of Google Cloud is that once you're federated in, you actually get a shell environment for your service. So let's go ahead and get this started. It takes a few seconds because what it's actually doing is creating like a little mini container. It's for your work. It's about 5 gigs of storage in there. So you can't really do much work in there, but it's nice. It's essentially, it's a Linux-based box. It's, you can run Linux commands like ls, cd, cat, etc. if you're familiar with Linux-based commands. So the way that was launched, again, just to make sure everyone's on the same page, at the top right hand, there's like a little Google Cloud, little terminal thing. So make sure you click that. And then it'll say like, are you sure you want to launch it? It'll look something like this. And at the bottom, you're going to click start shell. So that zooms in out like that. So nice thing is that if you don't want it to be at like the bottom here, there's actually like a way you can pop it out. I'm going to do that because I like to have it in another tab. So I can, for me, I like to be able to see the instructions on one side and the shell on the other side. So that's that button is like on the far right. It looks like a little pop-out window. If you hover over it, it's also a tooltip as well. So once you're actually in the Cloud Shell, you're going to want to make sure that what you're authorized in. Since we're not really doing any crazy Google Cloud setup here, where we have multiple users and multiple roles and groups, by typing the command in the right here, gcloud auth list, and this command is also found in the instruction guide as well, and you hit enter on that, you're going to see what you're essentially authenticated as. And for me, I got my Quick Labs user as a student. That's the user I'm in as currently. If you had multiple roles, you should be able to hop around here, like set account to this, switch account to that, right? But again, since for the code lab, let's not get too much into that. Just that you are authenticated as the user of this shell. Again, also there's also the gcloud config list project, and that'll show us our active project. At the top of Google Cloud, you can actually see the projects that are available to you. When you're taking the time and creating your own Google Cloud account, you may have various projects. Like you may have a UI project, you may have a backend project, you may have different projects that correlate for different services, and that's totally fine. But for this demo, again, we only have one project. We're not going to be creating a project here. We're just going to be using the one that's provided. And if you see, I ran the command, and actually, can I make this bigger? Because I can't barely see this, and I definitely think you guys can't. Hey, look at that. It's pretty good. Cool, so you can see that there's the project, and the project is the one that I'm in. So cool. So that's kind of things aside. So a thing to understand about regions within Google Cloud, there is an overarching region. So things like, if that gets bigger, and I can make that bigger too. Nope, I can't make that bigger. You'll see different regions like we are in Eastern US, we are in Western US, we are in Eastern Asia. Within those zones, there's the concept within those regions, there's the concept of zones. And those zones are essentially distributed data centers, which are actually separated out. So you have US East Asia 1A and B and C. Those are actually distinct regional data centers within the Google Cloud Platform. Just to kind of, you can read more into it. There's actually a whole section of documentation, but again, for the purpose of this demo, we're going to be spinning up in one zone in US Central. US Central being kind of central US, right? So let's actually get started with just using the UI. So the first thing we're going to do is we're going to actually go to this. Cool. We're actually going to go and launch an instance from the menu. So at the top left, again, where the Google Cloud Shell was at, where we went to that, you're going to see a bunch of options here. You're going to look for the option called Compute Engine and click on it. So when you get here, nothing is really going to be there because we haven't created anything, right? So in this lab, we're actually going to just go ahead and create one via the UI. So we can then translate that into the instance. So the name, we're just going to call it, let me see if I can make this bigger too. Hey, look at that. All right, cool. GCE lab. I don't think the name really matters, but just give it the name that they tell you to. The zone, we're going to just use the default, 1C. If it's not the default, there's a drop down, but C should be the default there. For this, we're going to use an N1 standard 1. It's just one CPU, which is running with 4 gigs of RAM or 3.75. Just again, this is a very light demo, so we don't need anything crazy. But with Google Cloud Platform, you can actually go up as crazy as like 96 cores. Don't do that on your personal account unless you have money to pay for that, because it's going to cost you a lot of money. Yeah, it's pretty crazy. Just one core. Let's not go crazy here. So again, to get started, we're just going to leave the default boot disk. We're going to be using Debian Stretch. That's just Linux. So for those familiar with like Ubuntu, stuff like that, it's a very similar basic OS as well. All right. And then in the firewall section, these are pretty bare bones and very basic allows. Within Google Cloud Platform, you can actually get more specific if your server runs on different ports and such, but we're going to allow basic HTTP traffic. We're not going to have SSL or TLS, so we're just going to allow HTTP. So again, just verify your options. Make sure you have the 10 gig image with boot disk standard. Just allow default access, and in the firewall, allow HTTP. Yep, that's all good. And that is good. So we're going to go ahead and create the create. Before I hit create though, so you're probably wondering, like, you're going to do this the first time, and you're going to be like, wow, this is cool. And you're going to do it the second time, you're like, wow, this is cool, not as much. And the third time, you're going to be like, okay, this is getting repetitive. For those who are very familiar with CLI, you can actually, the nice thing about Google Cloud Platform is it actually gives you this some sample JSON to actually submit via the API. So you can do this in the future in an automated script, through an automated process, however that may look. And you can actually kind of do this. That's like a REST endpoint, and then there's like a command line option too. So that's a really cool thing I personally like a lot. It's being a DevOps engineer. But I'm just going to go ahead and create. The nice thing is that you don't have to wait for any spinning bars. It's all going to be kind of just done in the background. In fact, at the right corner, you'll see like this kind of spinning thing that's going on. So if we kind of hide this and select this instance, you'll see that the instance is kind of spinning up back here. Why is it still so big? Oop. Make this bigger. It's still spinning up there, so it's going to take about a minute or two to kind of get up and start it up. Cool. So again, I'm going to be going for the sake of time a little bit fast here because we already have 19 minutes, but that's fine. Once the operating system and the VM is up, you can actually go ahead and click, let me find my window, click the SSH button here. And what this is actually going to do, I don't have pop-up blocker. Pop-up blocker is sometimes great, sometimes bad. There we go. Cool. What it's actually doing is allowing me just SSH via the browser. So I don't know many of you how many maintain infrastructure, and you may have SSH key pairs, username, passwords. With this, you can actually just translate transfer SSH keys. The Google Cloud takes care of you for that. So I'm actually right now on the Linux box that we just actually booted it up. So if I go to uptime, you see it's only been up for about a minute now, which is pretty fantastic. No more kind of remembering passwords. I know for me, there's a lot of SSH keys possibly that you have to maintain and wrangle and make sure you keep secure. So that's a really nice advantage of GCP. So now that we actually have a shell, and we're actually on the instance, let's go ahead and get started with something you should probably never do in Linux land is always sudo. So yeah, so we're going to sudo. Definitely with great power comes great responsibility. Sudo is very great. It allows you to do a lot of things, but if you're not careful, you could definitely ruin an operating system. So be careful with commands you run as sudo. So the first thing we're going to do is apt get update. I believe you can just do apt update too, because that means stretch 9. So what this is actually doing is it's going out and fetching the latest releases that you can install for your system. So it's apt get update. Again, all this is on the page here. And also for the folks that are already logged in, you can also like hide it, so you don't have to keep seeing it, right? So you can actually see the instructions more. And in fact, I'll make this a little bit bigger since that's probably more important. You'll see getting all this updates, and we got it. The first thing we're going to do is we're going to do apt get install nginx -y. -y means yes. If you didn't put -y, it'll actually say, "Do you sure you want to install?" And you're going to say, "Yes, I want to install." That's why I told you to install it. -y is kind of a way to circumvent that. It's installing a bunch of things, libraries, nginx common, stuff like that. Once you install it, if you do ps awx grep nginx, you'll actually see that nginx is up and running because we installed it and we have it running and listening. It should be listening hopefully on port 80. And let's go ahead back to, where did I lose it? Where'd it go? You're here somewhere. There you are, hiding. When you're here, you'll actually see an external IP. So when you actually click the external IP, this is actually a public website now. It's actually taking traffic. By no means is it production ready, but we have a very basic web server. So if you have a small blog, you can go ahead and host it up. You can put your images and stuff like that and share it with the world and create a basic website. And that's all fine and dandy, and you'll see, like, again, the welcome to nginx. So that's great. But again, like I said, this can get very tedious. I mean, it's pretty cool. We were able to spin up a server in probably, 5 minutes? And that's given that I was going a little bit slower. But let's actually go ahead and go back to doing this via the command line and see how that looks. Is that it? Nope, that's actually this. So I'm going to exit out of here. And I'm going to exit out of this too because I'm done on that VM. I don't need to do any more work on there. So if I find it, it should be here somewhere. Boop. Cool. So the key thing to remember is the shell that we just spawned by clicking that SSH tab is different than the one used for your Cloud Shell. For Cloud Shell is essentially an administrative entry. It's essentially a administrative VM that you can do commands within the scope of Google Cloud. When I hit that SSH button, I'm actually on the physical box. It's the important thing. And maybe I'm being a little redundant, but it's a very important thing to take away from that. So I'm gonna actually close this session and I'm gonna go ahead and just restart. So we're gonna use Google Cloud, the command line tool, and actually spin up an instance. So let's go ahead and do this. Activate the shell. If you haven't done it again, you'll see it down here. Again, if you want to pop this up into another tab, you can. For this purpose, I'm gonna hide the info panel, leave it down here. If I can make this bigger though, ooh, nice, I can. Look at that. We're going to use the gcloud command. So the way this works is you do gcloud For those, I know a lot of you may have used like things like Amazon. This is very similar to like AWS CLI, where you use AWS and a service name. Here's gcloud and the service name and what you want to do. So we're going to do gcloud, and then within compute, we're going to launch instances. So it's gcloud compute instances. Again, this is in the lab. We're going to create GCE lab 2. And again, this is going to be in zone US central 1-C. I know I'm typing pretty fast here, but the command is also within the lab here. You could, if you could just go ahead and copy that as well. Yes. Sorry, can you maybe you repeat that? In this show, you can do that. Yes, you can. There's a way, but the problem is with there is it's within local scope. That is a short-lived VM. It's very ephemeral and can get torn apart, right? You probably most likely would like to have a physical VM to host your infrastructure, because this is kind of spawned per role, right? This is more like this is what I'm typing right now is more or less kind of a look into your account where you can show users, show my running instances and stuff like that. But we'll get into that in part of the lab. What's up?
What was the access code?
The access code?
Yeah.
For?
I don't know, I got people.
Access code. Access code for the labs? Yeah, we're good? Oh, for the access code for the labs. Again, so sorry for that. It's actually in the Meetup. So once you created your account, you verified your account and everything, and you logged in, you're going to click that link, and it'll actually prompt, once you're on that web page, you click enroll for this lab or this quest. Once you're on there, you'll be able to start the lab, and it'll say use my subscription. It'll be there. We will actually talk about that. We'll help out people that are kind of stuck there too. Cool. So I'm going to go ahead and hit enter here on this command. Oh, look at that. I had a typo. Oh, I'm missing a 1. I'm missing an L. Central 1. So now it's not scripted. It's going to take a few seconds because it's launching. In fact, if I'm not mistaken, you should actually see it up here. Great. If you once you type in that command and you hit enter and you refresh the page, you're actually going to see that we actually created another VM just by the command line, which is pretty cool. And then, as many of you are aware, now that you did it once to the command line, it's fair game. You can chuck it in a bash script. You can, put parameters, do whatever you need to kind of get that there. Access denied. Oh. Oh, to the. Oh, yeah, it may take a few seconds to start. The reason access denied here, yeah. Let's see. It'll take a few seconds for it to boot, but. While we're kind of all typing that up or getting here, the nice thing is you can run gcloud compute create instances help. In fact, if I make this bigger, gcloud. If I type in the right box, gcloud compute instances create -- help. It'll actually kind of give you a help page of what you can actually put, because I don't know all the options and command line flags, and what if I don't want 10 gigs and I want 100 gigs and stuff like that. So that's all there for you. And if you find it repetitive that you keep having to enter the zone or the region, you can also set that within the gcloud config. Again, that's in the instructions here too. Once your that instance is up, you can actually do gcloud compute SSH GCE lab 2. So the way this command works is you do, again, the base gcloud, the service compute, the command you want to do. In this case, we want to use SSH, and the name of the instance. We called it GCE lab 2 if you didn't put the name that you put in the command. Again, and you also have to do the zone. It's repetitive, but again, that's what the command before one was for. And from there, it's saying, hey, do you sure you want to be logged into this? It's going to ask you your public cloud, your key, and you're going to copy it in there. Great. I'm not going to generate a passphrase. I'm just going to get in. It's uploading my SSH like that. What's up? That's interesting. I'm not sure. It should. Are you scrolling through the page too as well and kind of side by side? Huh. That shouldn't impact your progress because at the end of the day, when you hit end lab, as long as you get to the bottom of it, it'll still give you credit. It should. And if it doesn't, that's a support question. So they should definitely square that away. So I guess since now I SSH and I'm actually on the box, you can see here it's again tiny, but I'm on the GCE Lab 2 server. Again, ls, cat, stuff again, commands that I have on the box. And I'm on the box. So I can actually apt get update. Oh. See, I'm bad. I forgot to do sudo. Shouldn't do sudo. Be careful. Whenever you have a problem, sudo, yes. Apt get update. It's great for demos. Cool. And I can actually do apt install nginx-y. It's doing the same things earlier, switching all my packages. And if I go back to compute, I should see a public IP. Hopefully. PS grep nginx. Cool. Hopefully this works. Let's try it. I forgot to put the firewall. That's why. Well, if I put a firewall, you can modify the firewall. I'm not going to get into it in this lab, but I forgot to put the firewall. So once you do that, you'll get that page. So that's the first lab. Yeah, I know for some of you this may be very boring. Don't worry, it's going to get a lot crazier. So with that being said, you're on the start of the GCP Lab Essentials. When you're done and you're wrapped up, it should say 15 out of 15. If it doesn't, I've actually done it in the past, and it just says 0 out of 15. You should enter and lab, okay. And you ask like a survey of how well you submitted, satisfied with the lab, submit it, and we should be done with that lab. You can actually then click the top arrow, and if everything worked well, you should see like a little green thing here saying that it was all completed and everyone's happy. I am going to get started on the next lab with gcloud and provisioning services with Cloud Launcher. But before I do so, I'm just going to make sure, does everyone find that link? Is everything okay in terms of sending it up? What's up? No. Have you ever enrolled in that before? Can you move it in? Signed up and you verify the user and everything? documentation on Kubernetes support. It may have been that the code has exhausted. Don't worry, everyone will get the free subscription, and we'll get all that squared away. So, yes, yep. No, you shouldn't. Once you're done, you can end lab. As long as you scroll to the bottom, it should finish. As long as you kind of push the rest of it. Yeah. If even if you don't finish it, I think as long as you end lab, it should give you credits. Yeah. Cool. So with that being said, let's just get started on the next lab. I know we have a break, and I'll probably be ending up going around and helping a few of y'all. So the next one that we're going to be doing today is provisioning services with the Cloud Launcher. So again, to get into this, you go back to the GCP Essentials track, and you scroll down, and there's provision services with Cloud Launcher, this lab. And we're going to go ahead and click Start. Again, I understand some folks didn't get a chance to get started. That's to get the access. We'll go ahead and square those away during the break. But for those that do have access, click on Launch with Subscription or with your credit. There we go. How many tabs do I have open? Close this out. Close this out. Huh? When you hit the shutdown, it'll actually start the process of destroying that account. So you'll be kicked out one way or another. You can close it if you'd like, though. Yeah. So I think we're officially taking a beating on the Quick Lab server because it's taking an extra minute or two to spin up labs, which is fantastic. So good stuff. Once you're on here and you start the lab at the top, again, very same process. Not to bore you guys with the intro, but again, start lab. We're gonna this time around we're gonna open up the Google Cloud Console, and again use another account. Copy the username. Put it in. Copy the password. Put it in. Hit next. And we're going to hit accept. Again, we're going to hit done. And I don't want emails, but I will agree to terms of service. And that should start getting things done. Cool. So in this lab, now that we're actually in, we're going to be using the native Cloud Launcher. So this kind of gives you a quick way of using the GUI to kind of launch basic services like Ruby on Rails, some WordPress sites and stuff like that. For this, we're just going to do an Nginx image. So the way we're going to do this is go back into Google Cloud, and in the left-hand menu, you'll find Cloud Launcher. If you don't find it here, it's going to be in here somewhere. I just got to type it in here. Also at the top, you can probably type in Cloud Launcher, and you'll see like a little rocket next to Cloud Launcher. So you can go ahead and click that. These are all essentially partner solutions, so you may find things like SQL Server, SAP related projects, Nginx Plus, stuff like that. But for today, we're going to be using Nginx by Bitnami. So Nginx. There's a search box here. Search for solutions. Nginx. And we are going to find Nginx certified by Bitnami. And we are going to hit, for sure. Yep, that image. And we're going to launch on Google Compute Engine. So click that button. Again, not to go too fast. I got there by hitting the search button at the top. I typed in Nginx in the little search box here. There's Nginx certified by Bitnami. We're going to click that one. And we're going to launch on Compute Engine. Again, where it presents you, the nice thing about this is kind of a ready-made way of launching a system and a service kind of prepared by a third party. So many companies can do this. It's kind of a software as a service. It tells you like the estimated costs, software involved in running the stack. It's kind of nice. It tells you all that information. Different stacks require different information. So from there, we're going to be able to type in everything. So we're just going to call it Nginx stack. We're going to leave the same name. We're going to pick a zone that's closest to us, and we're going to allow HTTP and HTTPS. So Nginx stack 1, that's fine. We'll pick US Central 1C. Why not? Something smart, close to us. 10 gigs is fine. We're going to allow HTTP and HTTPS, and just hit the deploy button. So What's up? Yeah, it's pretty much going to run just run-of-the-mill configuration. With different images, of course, there are going to be some that you need to do specific configuration, like maybe you want it to be in Europe, or maybe you want it to be somewhere else, but just go ahead and hit the deploy button. So it's going to be launching. The nice thing about this is this is essentially managing your entire deployment. So you can see like the script that's actually being used as a template to launch your instance, the software that's being done, and you can see the state of this Nginx certified Bitnami. So Bitnami is actually essentially like a web hosting platform. So essentially it does a lot more than just like your basic run-of-the-mill Nginx server. There's like login and temporary backend, some CDN stuff related to it, and documentation, how to get in contact with support. I actually, unfortunately, don't run Bitnami much. I don't know if maybe someone does, but yeah. So it'll take a little bit to launch. It's setting up all like the certificates and software, installing, booting the OS. Yeah, it does take a little bit for this to start up. So. Hopefully in a second it should be up. Cool, there we go. Yay! All right. So after about a minute or two of waiting for everything kind of in the stack to be set up, you'll see, congratulations, you're now running Bitnami Nginx, the version of Nginx in the cloud. There's a quick start guide. Again, this is setting up a lot in the background, so things like phpMyAdmin, there's documentation, stuff like that. So to kind of see this in action, just to make sure this is in fact a server, there is a blue button on the left here, visit the site, as you saw when I clicked to kind of see the page here. But then you could also, again, use the SSH and just kind of log in via the browser via SSH. And that is way too tiny. There we go. Cool. And if I clear it, again, we're on there. If we do ps aux grep nginx, good. I mean, I could probably even do vim opt bitnami nginx HTML index.html, and I can say sudo. Just to show that we are on this box. Hello, GDG Chicago. Save it. And if I actually go back and I visit the site, and I actually hard reload this, you see that, yes, I modified the running web page. Nothing miraculous. It's just showing that this is, in fact, a VM running Bitnami's Nginx. And we use the deployment manager via the click of a button, no command line. So again, this is a nice thing that GCP is pretty versatile and is open for many workloads, right? So with that, that's actually pretty much it for that. So I know it's kind of a boring small lab, but it's essentially kind of highlighting how you could use with third-party services, maybe images created by a third party. Say you're not used to building up a Mongo server, you could probably search to see if there's Mongo in there. You could probably see if there's like a database that you could launch on an instance as well. So with that being said, not too much in here. I know some of you may be still getting through it, but I'm going to go ahead and end this lab here. And I'm just going to submit it. Very tiny lab. Definitely not 30 minutes, but yes, you can kind of see a lot of stuff. Ooh, we're starting to get to the fun stuff. All right. So from here, we're going to do creating a persistent disk. And again, the way I got through this is clicking at the top of, actually, let me close this out. Yes, leave. Close this up. Again, if you click the little up arrow here, you'll get back to the GCP Essentials. We are now on the creating a persistent disk. So I'll give everyone a few seconds to kind of find this link. This is going to be creating like an actual disk separate from your VM that's not ephemeral. So within GCP, if you have a VM and you destroy that VM, there goes the storage as well. There are many cases where you want a separate storage volume such that you can attach to your running instance, destroy the instance, and bring up another instance in the future and attach it as well. So it's just so what you have stored on that VM doesn't go away at the end of your when you're done playing with it. After this one. Yeah, after this one, yep. So let's go ahead and start this lab. And again, launch with credit. After this lab, we'll take about a 20 to 30 minute break. I'll be happy to help anyone who's stuck and guide everyone if there's the washrooms over there. So get started and hit launch. Come on. It's in the background? Interesting. It's provisioning right now. Again, not to bore you with the details, but these are essentially the same things, kind of guiding you through the quick lab stuff and how to log in. So again, as we did in the last two labs, we're going to go ahead and click Open Cloud Console. We're going to use another account. And don't worry, you can delete these accounts when you're done. Log in. We're going to copy this password. Log in. Yes, we accept. No, we don't need recovery questions because this is a temporary account. Yes, I want to accept the terms of service. And no, I don't want email spam. So once everyone's logged in, we're going to go to our trusty tool, the Cloud Shell. We're going to be in the Cloud Shell a lot this evening. So we're going to go ahead and launch it up. I'm going to hide this menu. It's going to take a few seconds. We're going to go ahead and create. We're going to go ahead and create a new instance. So if you're familiar, if you're more comfortable doing it via the command line, yeah, that's the way the lab tells you. If you want to use the GUI, you can. Just refer to the way you did it in the first lab. So for this demo, we're just going to do it via the GUI here, or via the command line. So it's going to be gcloud compute instances create GCE lab, again, the name of the VM, and the zone that we want to put it in. And I'm going to put it in US Central 1-C. It's going to take a few seconds. Woohoo! All right. So as you can see, we have the command line. I just launched another instance. Again, it has an internal IP and everything. So now this instance, again, has 10 gigs of storage. Those 10 gigs of storage is when that instance dies or gets destroyed by whatever means, what you ever were running on there is gone. So very common, it's an infrastructure, you will have a separate disk that will long live and contain configurations, websites. So that way you kind of separate your process level from the actual configs that you need. So what we're going to do is gcloud, again, to start the command, compute, which is the service. We're going to be targeting the disks. This is just to kind of show you here in compute. There's disks, so you can kind of see where all this kind of correlates in my command on the command line. Disks, create, or if I could type in there, create, because I want to create a disk. We're going to call it my disk. The size I'm going to do is 200 gigs. Go big or go home. Zone US Central 1-C, because you want the disk to be in the same zone as your VM. That's very important. When creating a persistent disk, if you remember early in the code labs, when we first started, I mentioned the concept of regions and the concept of zones within those regions. The best way I could describe it, and maybe it's not always correct, but it's very easy to picture this. Picture every zone, every region as a part of the world where these data centers are located, and in there, there's various data centers, zones within there. So there may be one in Chicago, there may be one in Schaumburg, and there may be one in, I don't know, Joliet. All still in the central region, but very far apart. Maybe a little bit over an overstatement, but think of it like that. Anything configured in each of these zones have to kind of live within that zone. So if you spin up an instance here, say in Chicago, you're going to want that disk to be in Chicago because the same data center. They need to be on the same plane for that. There's ways around that, but for now, that's kind of the basic way of getting started, getting your head around that. There's documentation which kind of definitely goes into more detail around that. So very fast, we created it, and you'll see that it's done. It's PD standard, and it's ready to be attached. So you can attach the disk to the running virtual machine. So let's go ahead and attach the my disk to the instance that we created earlier in this code lab, in this same code lab. We're going to do gcloud compute instances attach dash disk. And again, as I mentioned earlier, a lot of these commands have dash dash help. You don't have to know the commands right off the top of your head, because I surely don't, and I don't expect anyone to, unless maybe this is your job to write this tool. But there's definitely a lot of crazy commands and things you could feed into these commands. Attach disk, GCE lab. Attach disk. We're going to attach a disk to the VM called GCE lab. The disk is with dash dash disk. It's called my disk, and the zone for all this to happen in is US Central 1-C. It's going to take a few seconds to attach. Okay, and there we go. It's attached. So we supposedly attached it, right? But we want to verify that it's actually up and running, correct? So the first thing we're going to do is, again, log into the box with gcloud compute SSH GCE lab dash dash zone US Central 1-C. So again, you have to put the zone. If you get tired of typing the zone, there's a way you can set it. But for this code lab, let's just kind of run through it with this. It's going to prompt you saying, you sure you want to log in and put this key there? Yep. Do you want a passphrase? Nah, let's not do a passphrase. Cool. So it does it. Now it's actually uploading a key to the server securely. sorry? You could make disks in multiple zones, that's correct, and those VMs can then leverage that persistent disk, that's correct, yeah. And that's kind of a way you can get around that. You could look at things like network file storage, where you could attach disks kind of around, you kind of have your NFS in one server and mount that instead. That's another common strategy. This is just using the native GCP way of attaching a disk to that VM. Yeah. Cool. So I think I'm in the box. Yes, I am. So Debian Linux. Woo! Not very surprising, but I got into the box running the SSH command. We could find the disk ID that we just attached by doing ls-l/dev disk by-id. Again, this command is in the guide. And you can see here, if you look somewhere here, there's a persistent disk. Persistent disk. Oh, there it is. Yep. There's a persistent disk 1. That's the one that we attached. Yeah. If you wanted to give it a different name to make it a little bit more obvious as to which disk it is, the guide also tells you can use -- device name. So again, I don't know all these commands off the top of my head, but it's good that we have documentation like this. So just attaching the disk doesn't really do anything because you just essentially now have raw 200 gigs. You still have to create a file system on there. I think it actually warned you here. Yeah, earlier it said new disks are unformatted and you must format and mount a disk before it can be used. You can find the instructions here. Fortunately, those same instructions sound like they're here as well. So we're going to go ahead and just run through these real fast. First thing we're going to do is we're going to make a directory called mount disk. So sudo make dir. Hey, nice job using sudo instead of logging in as root. Cool. We're just going to create a mount point on the file system for Linux. We are going to type, or actually I'm just going to copy this crazy command because I don't want to type that. So in fact, the nice thing about Quick Labs is if you don't want to type it, you can actually just hover over on this little clipboard thing, click that and copy, and paste it. So here we're going to make a ext4 file system. We are going to mount the persistent disk 1. We're creating our persistent disk 1. We're going to hit enter, and we watch inodes being created. Woo. The land of infrastructure management never gets boring. Should be here done soon. That should be an option. I think by this demo is just a standard non-SSD because it's just a free tier. But I think there actually is a command line flag to specify like the IOPS and stuff you want. So you can say like, I need high performance reads on this disk. Yeah. It ultimately depends. I know there is a free tier. I don't know the bounds of it, but you can look that up. There's definitely a free tier where you can say we'll give you a disk of this size up to this many IOPS. Yeah. Cool. So if everything goes well, we just formatted the disk. This is very similar if you were to buy, like imagine, I like to compare this, you bought a hard drive, like, you know, you went to Best Buy or Micro Center or something, you bought it, you put it in your computer and you're like, wait a second, where's my 200 gigs or however much you bought? You still have to format the disk and have it ready for taking files for your file system. Now that we did that, we actually have to mount the disk. So we're going to actually sudo mount, and we're just going to do the discards default, the name of the disk. So this is like dev disk by ID and the name. Now that's formatted into ext4. And we're going to mount it to the mount point /mnt/mydisk. And that doesn't look like we did anything, right? But if we do df-h, we should see. Yeah, there we go. On the bottom over here, you actually see that we now have at /mount mydisk 186 gigs of storage. This is a lot of Linux to be tossing at some people that may have never seen Linux. So there's definitely a lot of great documentation on disk storage within Linux. In fact, even the GCP documentation is a great way to get started on that. So within Linux, again, this is not something, if you've never seen Linux, I know a lot of folks here may use Windows. There is the concept of when you restart the system, you want that volume to be reattached automatically. There's a fstab file. And in this etc fstab file is essentially a list of mount points that on boot this file is read and saying, I need to mount this volume to this point. So we're going to go ahead and do that. I'm going to go ahead again and copy this. And I'm going to go to end of the file line here and paste. Woo. There's, oh, whoops. I gotta make this bigger so you guys can see that. Nope, not up there. Go there, go. Back. There you go. Oh yeah, cool. If I make sounds, maybe it'll actually work. Cool, so I'm gonna copy the line. We're gonna actually do write out. So that's done with the command nano. I don't actually use nano that often. You're going to do, once you paste it in, you're going to Control O. Within nano, it's going to be hard to see. There's actually like the commands you can do. A little caret is like the control key. So Control out, write out actually saves the file. And then you have to exit the file with X. So yes, the battle of the text editors in Linux are fun. So we're going to write the file. You're going to hit enter. So it said I just wrote 2 lines. Great. And we're going to go to Control X. And now it's saved. We're back to the shell. And again, these steps, oh, look at that. Thank you, Quick Labs. And step 3 actually tells you to do Control O to write out, enter to confirm, and Control X to log out. Now that image will be saved. Oh, cool. This is actually what you were talking about with the SSDs. So there is actually a section of this lab where it talks about it. Google Cloud Compute Engine can also attach local SSDs. Local SSDs are physically attached to servers. They're tight coupling. They have higher IOPS, less latency. SSDs, I think we all, maybe would not, are flash memory. They are much faster. They're in most common laptops today. And higher IOPS, more read-writes, which is great. We are not using local SSDs. Ha, that's what exactly we're doing. So we're just using base storage. With that being said, that's that lab. I ran through that really quickly because I want to make sure you all have time to take a break and relax and to network a little bit. So I'm going to end my lab, but I am understanding there's a lot of technical difficulties getting set up here. So if you need to use the washrooms are back that way. Down the hall, you'll see a sign saying restrooms. Go down the hall, and then ladies and men's are there. The signs are appropriately up there. So please, let's take a break. Let's try and be back by 7:40, 7:35, and everything. So I'm going to swing around, and don't worry, help out as much as I can. So everyone just take a break. What's up? Yeah. I'll start working from the front to the back. How about this? So it sounds like a lot of people have the same issue. If you're having an issue, come on up here and let's all kind of let's make sure we maybe you do one sign up and everyone can kind of get figured out. So yeah, some few chairs and stuff. It should still give it to you. Yeah, one recorded and then they log this first. break. They've been pretty good about getting back to me within 5 to 10 minutes. So let me see if I can get a quick email up.
What account should I use?
So now you can hear me? Yep. All right, cool. Sorry, live stream folks. Yeah, this event is being live streamed too. So sorry. Apologies, folks, on the live stream. I muted it during the break because it was quite loud in the room. So we're getting started with the introduction to Docker Lab, and we're gonna again log in, copy the username, open up the console. We're gonna add yet another login to our login screen. As you can see, it's just getting pretty unruly now. Don't worry, you can remove those after the lab. We're going to click accept. We've been here before. We're going to hit done. We've been here before. We're also going to accept the terms and conditions because everything has terms and conditions. Cool. And once this is done, you're going to be back again in the familiar Cloud Shell, sorry, the Cloud Console that we've been playing around with all day. At the top, right here again, this lab is going to leverage the Cloud Shell to create and ship our Docker containers that we're going to do in this code lab. You can run Docker locally on your Mac with Docker for Mac, or also Windows, Docker for Windows, or natively on Linux with just the Docker package. This is definitely not limited here, but to make things easier, we're just going to use the Cloud Shell because it will have permissions needed to push to a registry, which is a place where you can store your images. It has basically everything you need. It'll make the lab much more efficient. So we are going to go back. We launched our console. We saw a gcloud auth list. Again, this should all be done. The first thing we're going to do is we're going to run docker run hello world. This is essentially the most common Docker command for folks learning to get started with Docker. So docker run hello-world, world, not word. This is way too tiny. I'm going to make this bigger. There we go. Is that too tiny? Yeah, that's way too tiny. I'm going to pop it up to another tag because then I can make it as big as I want and not worry about this. Sorry, y'all. Oh, Joel, that was not a good thing. Cool, there we are. I'm going to run that again, just so folks can see. Docker run hello world is actually quite tiny, so you probably didn't catch it, but if I run docker run hello world, you see how almost instantaneous that runs. It's because I already have that container image locally. In fact, I don't know if it'll actually show it. Here you'll see that the first time I ran it, hello world, it said, wait a second, I can't find that image locally. I'm going to pull it from this library / hello world. So it actually went out to the internet, fetched out this image, and put it locally. As you can see here, and by the second time I ran it, now the third time, you don't see that because that image is already installed locally. It knows where to find it, and it's going to use that for this image. It's an important concept to understand. Where is this here? So if we do, to show that, you hit clear. If this gets too noisy, again, I'm being pretty basic with Linux, but if you get a lot of noise here and you want to see just a fresh shell, you can type in clear and it'll clear your console. You can do Docker images, and we'll see that hello world with the latest tag. Tags are essentially a way of determining the version, latest being, give me the latest version, we don't care. The image ID and when it was created. Not when it was created locally, but when it was created and uploaded to wherever you downloaded it from. This image is 4 months old. Hello world doesn't really need to be updated that often, so it's not too shocking. Again, kind of showing that the image is already down, so if I run docker run hello world again, we just see it. Basically, this actually just contacted the Docker daemon. Docker daemon put hello world image from Docker hub because that's where it pulled it down. It created a new cluster, and it just streamed it out to the output. And if you want to be more ambitious, it says you could actually log into the box and run commands, but we'll get to that later. Docker PS shows you you're running containers. So right now, nothing's running. It's important to understand that Docker is around your processes, and hello world is not a persistent process. It just kind of starts up, says hello world, prints out all this beautiful output, links and stuff like that, and goes away. But with Docker PS-A, it'll show you all the processes that have ran and their current state. So if I make this a little bit bigger, yeah, that's nicer and easier to read. You'll actually see that it launched a container with the image hello world. It ran the command /hello. I guess that's how they launch hello world. I don't know. They have not actually created this container myself. And you'll see that it was created about 48 seconds ago, and it exited about 47 seconds ago. Because it started, sent the message, shut down. Started, sent the message, shut down. Again, if I do this one more time, you'll see an extra one here that about 2 seconds ago, I spawned this container, it launched, it did its thing, it went away. And it gives you some pretty cool names. The names are just generic names for your images. Sometimes you get some pretty cool ones. So I think how I named some cool stuff. So that's all good and great, but let's actually create a application, right? I mean, Hello World is fantastic, but let's actually go ahead and build something. So assuming you did the Hello World and you're at the step, you're at the build step, we're going to go ahead and make a directory with the command mkdir, and we're going to call the folder test. Very creative. To not gloss over Linux, but and is saying also run this command after this command. You could also do these as separate commands, so you could do mkdir test, since the thing already exists, or it does, and then you could do cd test. That's also fine too. I'm going to type clear to keep things clear. So you can just copy the command the way you have it. They're telling you to use this cat docker file command. You can. Be careful. This is not a very common way of inserting stuff. So I like to use something like nano or vim. So I'm going to use vim. I'm going to create a file called docker file. Vim docker file. So I understand that many folks may have never used vim. The way to get started with it is you hit your escape key. You do shift : apologies. Yeah, escape. I for insert. And we're going to start typing from node 6. You could probably actually just copy what they have there, but I like to, again, I said I was going to type everything in and explain it. So this is saying I'm going to use the node 6 AMI that's in Docker Hub. I'm going to set up a work directory on that container called /app. I'm going to add dot to /app, dot being the current location this Docker file is in. I'm going to expose port 80. So basically saying that this container is going to expose the port of 80 out. And the command I'm going to run, for folks who have run node servers before, is node, app.js. So it's going to use the command node against the file app.js. Don't worry, the file app.js does not exist. We will do that in the next step. And you don't have to type in a file if you're following the way I'm doing it, but this is also in that lab here as well. You can kind of see that. Do it either the way they did it or the way I did it. So you'll have 4 steps. The nice thing is this lab kind of walks through it. The initial line specifies the base image you're going to be using. In the second line, it's saying this is the current directory to run your container in. Add is going to be the contents to put in that container. And expose is saying we want to listen on port 80 for traffic. We'll get into that in a second. So we're going to save this. Within Vim, if you're doing Vim, to kind of make sure you didn't do this, if you were in insert mode, you would do escape and hit escape a few times. That's what I have to do, spam escape. You're back out, do shift : and then W for write, quit to Q for quit, and hit it. So if you cat docker file, you'll see that now I have a file, ls, I see I have a docker file. It's very important that the D is capital. So, and there's also a link to more docker file commands. This is definitely not the only things you can run. There's a lot of things you could add to this. Look at that lovely, lovely code. I am not going to type that for the sake of time, but I'm going to again, actually let me see if this works. I want to see if this actually just works copying this whole thing. Oh. What? To get out of cat, I think you do. Because they don't put it in cat. Because if you do cat app.js, it shouldn't be in there. But since we did at the top, we have an EOF. Yeah, it's just kind of wrapping, like start and end. Yeah. So yes, you can just copy that if you don't want to type that all out. I don't know about y'all, but I'm also a slow typer. So you can just copy this whole block and hit it, and we have a very basic web service written in Node with a library of HTTP. It's going to listen in on port 80. It's going to create the server. It's going to respond with a 200. 200s are good. With a content type text plain. It's going to respond back, hello world. And the server is running at this. It's the log. It's going to print out. So assuming you have that done, and if you ls in that directory, you'll see two files. You'll have a file called Docker file, which we kind of ran through earlier, and app.js, which is essentially JavaScript code. First thing we're going to do now is we're going to actually build a container. So the way to do that is you do docker build -t. We're going to call our app node app with colon 0.1. This is just a version. You can make that 1.0, but for the demo purposes, let's just do 0.1. And you're going to say dot for this current directory. Build in this current directory, look for the Docker file here. You'll see right now what it's doing is it's going out to Docker Hub. It's pulling down the node image. Again, remember I didn't have that image locally before. So right now it's actually going out, and we are, wow, it's actually pulling pretty fast. Look at that. Usually it takes a while. It's 131 MB. All right, cool. Sound effects make things fast. So if you clear, and you do now, once it's all done and completed, if you do Docker images, you'll actually see quite a few differences. And in fact, let me make this bigger so it's a little bit easier to read. Okay. You'll see that hello world, because again, at the start of the lab, we did hello world. That image is still there. We have the node image with version 6, which was created 12 days ago. And then we have node app. That's actually our app that uses the node image. So we have a dependency. Node is the base image. Node app takes the node image plus whatever we need and layers it on top. Almost kind of like a layered stack of pancakes. That's a good way of putting it. So that's great and dandy, but let's actually see this thing running. Let me make this a little bit tinier. So the way we're going to do this is we're going to just run it locally, not in persistent mode. So we're just going to do docker run -p, which is going to take port 4000. We're going to expose this container at port 4000, but the container itself is exposing at port 80. So it's saying 4000 for the container port of 80 here. --name. We're going to call it my app. This could be any name. This could be like my name is Joel, so it could be Joel app. It could be demo app. It could be whatever you'd like to run it as. But the next bit is the most important bit. Node app, the thing that we built in the last step, 0.1. You'll see if everything's working well, you'll see server is running at port 80. That's great. But we are going to open up another tab once you're here, because your shell is essentially locked up. You can't really do anything here, right? I'm just typing in gobbledygook because this process is essentially running here. So we're going to open up another cloud shell, and we're going to use the command line command curl to send an HTTP request to localhost port 4000. This is kind of alluding to a comment earlier of, well, how come can I run Nginx on the local cloud shell? And in theory, you can. Should you? Most likely not. But this is kind of showing that I sent a request to the local system at port 4000 that went to Docker, and it said, go that from 4000 to port 80, and Docker just said, or the Docker container itself just said, hello world. Not very exciting, but it is nonetheless a lot of concepts just stitched together. I'm sorry? A lot of things tossed, but it's pretty cool nonetheless. I'm just saying that it's not very exciting that it just said hello world, but it's all the concepts we did to get there are definitely a lot and should not be shrugged off. It's a lot to get to where we're at. Yep. 4,000? Yeah. So if you looked at the last step, you see that I did docker run -p 4080. In the Docker file, if you remember, I said expose 80. So this is essentially mapping on the OS port 4000 to forward it to port 80 on the container. So it's saying anything I get on the OS at port 4000, take it to the container at port 80. So it's kind of like a map, essentially. Yeah, you got to follow it through. And that's why when I do a curl to the machine at 4000, localhost being this machine, the cloud shell. Yeah. So we're going to actually close the initial terminal. So we're going to docker stop. So let's actually, as long as this terminal is here, it's going to keep running. So if you want the container to run in a background, you have to put it in daemon mode. And that's with a -d option, and we'll touch on that. So the way to get that to start is, if that container is running, you can do docker stop my app. That's what we called our container, right? And again, that's a Unix thing where you're saying, and also run this command, docker rm my app. Should actually kill my first session here soon. We are gracefully stopping my application. Yay! So as you see here now, because in the other shell, I did docker stop my app. My shell here is now freed because it stopped that container. And it also removed that container. So that's great. So that was fine and dandy, but as you saw, that locked up my shell. So let's go ahead and rerun that command. Docker run -p 4000, because again, 4000 is a port. That could be any port you'd like, by the way. That doesn't have to just be 4000. It's not a magical number. It could be 4040 if you'd like. But for this demo, we're just going to do 4000 to the port of 80. --name, my app. We're going to do -d for daemon, so it'll actually run as a process. And we're going to call node app 0.1. You'll get shell ID back, and now if we do docker ps, remember earlier how hello world just didn't really show anything here. You had to do -a, and you saw it was exited. Now Docker is actually running this. And it's actually, let me make that flat so you can see it. It's actually running, it's created, and it's been up for 4 seconds. If I do it again, it's been up for 19 seconds. It's been up for 21 seconds because I have not stopped it. It's running right now. You can visualize this for the sake of simplicity as you just essentially booted up a VM running on your instance. But it's definitely not a VM. There's a very clear distinction. It's running as a process on your OS right now, on this machine here. You can actually see the logs with the command docker logs. So if you do docker logs, the container ID, the container ID was spewed out in this giant hash, but pro tip, it's also in the docker ps 94b17, but I think we're all pretty lazy and I don't want to type that, so you can actually, you can type up to the uniqueness of just 94 and it'll echo it out. You don't have to type out the whole container ID. You just have to type out to enough to make it unique. So if you have like 2 containers running at the same time, and let's say they're both 94b17, you would just have to type in docker 94b17 and then whatever's unique. So C in this case. Alternatively, if that's too much, that's fine. You can actually just copy that whole thing with Control C or Command C. That's also fine as well. You do either way. Just shortcuts I like showing sometimes. So that's how you can get running logs of your system. As you saw in the example, though, I really didn't do anything crazy in this. It's just saying the only log that it's actually going to print is console.log server is running. If I was to put like hello GDG server.log or console.log there, you would also see that step there too. But I didn't do anything crazy with logging. Let me get back to where I was. lost my place. Look at that. Oh, cool. Here we are. So that's all fine and dandy, but let's actually go ahead and modify this container. Let's actually do some changes, right? We have a process running right now, but let's actually go back into the test directory if you're not already there. The way you can do this is you can cd test. If you're not there, you can just do cd and then cd test. You can do ls, and you can see that the app.js file, this is getting too cluttered, sorry. Let's do ls, and you'll see there's two files, app.js and Docker file. For this demo, we're just going to go ahead and change the response. As we saw in this response here, it said hello world, but we're going to make it say something like welcome to cloud. So I'm going to open up with Vim, app.js, again, covering Vim basics, escape, escape, insert, go to the line that you want to edit. I want to modify the line that says hello world. It's right under the line that says content type. I'm going to make it say, welcome to GDG Chicago, because I want to be different, not do what the lab tells me to do. So once you have your typed changes, you're going to hit the escape key. You're going to hit the colon, WQ for write quit, and save it. And now we have made a change to the file. This still has not done anything, just showing, still saying hello world, nothing fancy. But if you do docker build, as we did earlier, -t with a tag, we're going to call the demo app called node app 0.2. So if you remember, we did 0.1 early on. 0.2 is the next one. And we're going to say use this directory, this Docker file, to build that container. This is now going to pick up the changes that we made in that app.js. If you look, you're probably wondering, like, well, the first time it took forever. It's kind of using, again, using as we're building on this, we already had the Node 6 image. We didn't have to re-download it. It used it. It's going to go ahead and create the rest of the steps, create that work app. But the long bit is once you have that image locally, the nice thing is you don't have to go out to the internet and fetch it again, which is fantastic. So we just created our second image here. So now that we have two images, and we can show this, wow, man, I'm not typing well. Docker images, we have node app 0.1 and node app 0.2. We can actually do docker run -p. Now this is very important. You can only have one port, the container can only run on one specific port. So if you already have a container running on port 4000, that port is essentially locked to that process. You can't have two processes running on the same port because you'll get conflicting things. So what we'll do is we'll just do port 8080. This is another port to port 80. Same concept as before. The request is going to come in on 8080. Translate that back to the Docker container at port 80. --name, my app 2. We're very clever, as you can see. We're going to do -d for daemon mode. Node app 0.2 because we want to launch the latest image that we created. And that just spat back the Docker process. But if I do docker ps, you'll see that now I have two containers running, 0.1 and 0.2, which is fantastic, and that's exactly what we want to see. So if I go to my next terminal back, since I still have that open, if I curl port 4000, I get hello world. But let's say I want to make that port 8080, and I get welcome to GDG Chicago. Again, not the most exciting, but we did cover a lot of topics. We essentially made a change, built that new container, and launched it as well. And there's now two containers running on the system. In this module, containers. Cool. You can also use to debug. There's a nice step of using looking at the logs. So you could do something like docker logs -f to kind of let it continuously stroll. And the container ID. So I'm going to put this one. Nope, that's too much. That one. and you just see the logs. If there were more logs, you would see, hits there. I should have probably done that so you guys can see the concept of that. Not very exciting, so we're going to Control-C out of that. The next one is Docker exec. So there are maybe cases where you're debugging something and it may actually be advantageous for you to log into that container and run some commands, right? I know myself as a Linux admin, sometimes I run into an issue, I have to log into the box and do some commands, I'm like, oh, there's a problem, this is missing. You can do that with Docker exec -IT, which is going to be interactive mode in a TTY session. You're going to copy the container ID that you want. Again, that container ID is gotten by doing Docker PS. I'll make this big. You're going to have container IDs. I'm going to log into the one that's called .2. So we're going to do Docker exec -IT, the container, and I'm going to spawn the process bash. Bash is essentially the command line way of getting into the container. And now I have gone from it's not very clear, but I've gone from my Cloud Shell and it now launched a bash process in my container. And you can tell because I'm in the /app directory. If I ls here, I see my app.js. If I cat app.js, I see my file because that was what I wanted in my image and stay layered together. You can do, you can see this. And you can do various things like you can do ping, google.com, stuff like that. You're essentially in that container. You can exit out, and you'll be back into your Cloud Shell. Within Docker, there's also the command to get the metadata of your container. Metadata, think of it as, it's not so much the actual data in the container, but more or less like, when was this container created? What are the commands used to maintain and run this? So this can be done with Docker inspect the container ID. I'm going to use the same one that I've been using, and you'll get a lot. You'll get a lot because there's a lot of metadata about the containers, which is great because when you're scripting or coding and trying to develop automation around this, you can use this data. So you can see like, what's the status of it? It's running. Is it still running? It's true. Was it paused? No. Was it killed? No. Is it dead? No. The image ID used, drivers, ports, IPs, a lot of stuff. So a way to get the IP is actually if you copy this. Oh, whoops. Container ID is missing because I did a bad thing and copied this example. Where's my... So with Docker inspect, it's basically saying look at the network section, network settings section under networks and get the IP address. So if you look here, you'll see a section called IP address. And I put the container ID. Nope, that did not. There we go. It'll actually print it out. And if you look here, this is the metadata, network settings, under network, and IP address. It's also there. It's a way so you can like extract data out of the metadata. So you can create charts, you can use that for automation, however, whatever you need. This is fine and dandy. This image is local, but say you're on a development team and you say, hey, you know what, guys, folks, I was debugging last night and I ran into this interesting bug and I want folks to see it. I want folks to like help me debug it. Within GCP, there's a concept of the Google Cloud Container Registry. So you can actually have a registry where you can publish your containers. If not, you can also publish it to Docker Hub. It is important to note that depending on where you publish to, your image could be exposed. So if you're working at an enterprise level, I don't know about y'all, but I don't want my company passwords to be publicly on the internet, right? I want to make sure that I publish to private repositories. And there's plenty of documentation on the web on how to publish to private repositories. In fact, this one here is a private repository. So what we're going to do is we're going to, that .2 image looks great. And you know what? It said, welcome to GDG, and I'm going to publish it. So I'm going to do Docker. In fact, let me clear this and make this a little bit bigger. Maybe that looks better. Much better. Let me close this out. That's distracting. All right, cool. Where'd it go? Cool. I'm going to do Docker tag node app 0.2 because that's the image locally that I want to publish. GCR.io is the address for Google Container Registry. GCR.io is the domain. Project ID. The project ID, again, can be found There's a few ways of doing it. You can go ahead in Quick Labs and copy it from here. If you are familiar with shell, you can use the environment variable dev shell project ID. Oh no, I hope this works. And do publish. Or sorry, you tagged it. So now if you do Docker images, you'll see that now you have a container for GCRIO, QuickLab, GCP. That's the name of my project. Yes, I know it's a mouthful. When you folks go and on your own time and within Google Cloud, you can name your projects however you want, but this is the name that we have to call it here. We are going to now push that image to the world. So the way we do this is with gcloud. Again, we're going to wrap the Docker command here with gcloud because we're going to use the authentication provided by gcloud and Docker to -- push, send this image up to gcr.io / and to make things clear, no magic, I copied, whoa, too much typing. There, copied the project ID / node-app 0.2. What this is actually now going to do is you'll see a push, hopefully in a few seconds. Please work. No, there's nothing wrong. Ugh. So take a few. I don't think I did anything wrong here. Nope, there it goes. Took a little bit, I don't know why, but a little latency there. So it's saying, hey, I'm pushing this up, and cool. So I pushed these changes up to GCR, so Google Container Registry. So the way this could be seen is if you go to your Quick Labs and you go here, and in fact, if you type in Container Registry, you'll see that I pushed a container called node-app, and here it is. Close it out. And there is .2. There's the container that I just pushed up on the screen. Sorry, when you go to, after you did the Docker push, at the top there's a search bar. You can do in Container Registry, and you'll see like this weird like 3-box icon. Hopefully folks can see that. If it's successfully pushed, you'll see node-app there in the registry location. It may take a while to push because you saw for me it took about a few seconds. I'm also hardwired in too, so let's test this. So right now we had the images locally. You could surely launch another image and a new VM and create Docker and everything. But what we're going to do is we're going to just copy Docker stop. So we're going to stop all the running containers. Once this is done. Cool. And you can see that Docker is stopped because now if I do a curl, I'm getting a fail. You know, it's not working. Nothing's listening on that port because I stopped those processes running on port 4000 and port 8080. The next thing I'm going to do is I'm going to remove all those images, or apologies, those containers with Docker rm ps-aq. So what I just did is I removed all those containers that I launched. The next thing we're going to do is we're going to remove the images. Cool. I'm going to remove Docker node 6. Remove any remaining images. It's going to take a few seconds. This is not a common practice. You don't have to do this. What we're trying to simulate here is a fresh environment, a fresh cloud shell where I never actually pulled a container down. And we're going to be pulling the one that I just published to the container registry. Takes a little bit here. It's doing a lot of looping through. Almost there. Woo! Look at that. All right. So now if I do clear that all out, Docker images. See, I have no images locally because I just deleted everything. I essentially wiped Docker clean on my local machine here. But what I'm going to do is I'm going to say gcloud docker dash dash pull. So remember in the other step, I did a dash dash push where I pushed that container up and we saw it in the container registry as seen here. I'm now going to do the inverse and pull it down. So that's going to be docker pull gcr.io slash dev show project ID node app 0.2. You don't have to do $dev show. That's a way of using an environment variable. You can again go back to your quick labs, copy this. In fact, that's what I'll do just to show it in simplicity. Copy it and replace those brackets that they have with the host ID, the project ID. Apologies. We're going to do that. What's going to do now is going to go out to GCR.io, the container registry, and say, hey, do I have a node app.2? Yes, I do. Let me start downloading that. And again, while this is downloading, I want to highlight the fact that it's not running. Nothing is on this box. It's essentially a fresh environment. All right, cool. So it downloaded the image, and I have it locally. So now I could go ahead and do that command again. So it's going to be to run the container. It's docker run -p port 4000 because I want to listen on port 4000 on my local machine and translate that to port 80 on the container with -d, the daemon. The container image I want to run, I can get that by running docker images. I can copy this beautiful string out. Docker images gets you the local images. You can alternatively just type the command from there. Docker run -p 4000. I lost my command. Port 80 -d. The command, the image ID colon the tag. So since I did .2, I want .2 to run. We have our container running. Now if I curl http localhost port 4000, ta-da! So that was a lot. We tossed. So basically what we did there is to simulate a fresh Docker environment, we wiped the entire environment clean by stopping all the containers, removing all the containers, even going further as removing all the images and base images like node 6. So essentially nothing was there. Like we didn't. This is a fresh environment. What then I told it to do was go out to the registry and download that image I published earlier, and now run it locally. Now run that same image that I just downloaded from the GCR.io. And I ran a curl and it said welcome to GDG. In fact, if I just keep doing it, just nothing fancy, but just welcome to GDG. And that one is it for intro to Docker. We do have some time for Kubernetes, and I would love to get started. The fear is we may not finish in time. So as I understand, you all have a month to run this stuff. So I'm going to start into Kubernetes. We may not finish the lab, so if you don't want it, you just want to follow along and watch me type, you can do that. If you want to follow along, please, you're more than welcome to. Again, these are self-paced, but this is quite a bit of an in-depth lab. But I do want to cover it because I know I promised that we would start it in this event. So I'm going to go back to this Docker and end my lab. So I said, are you sure? Yes. Submit. So I just killed the Docker one, and then I'll just kind of get a quick start into the Kubernetes one. We probably won't be able to get too far into it. So we covered a lot with the basics of Docker and images and running them locally. So what is Kubernetes? That's a great question. Kubernetes is a way of orchestrating and maintaining your containers in a running state. So as you saw, for example, to publish my changes, I had to do docker run 0.1, docker run 0.2. Wouldn't it be great if I could say run this deployment, and when I make changes, just roll it out in a smooth way. So that way it kind of removes the human intervention way of doing that stuff. Detecting on things like a push of an image to a container, launch that up. So let's go ahead and get started. The great thing is Kubernetes is one of those interesting projects that was initially created by Google. It was then became a cloud native foundation app, and it's actually one of the first apps. Actually, it is the first app to graduate from Cloud Native Foundation as a full-fledged app, which means it's pretty much here to stay. If you're not familiar with CNCF, definitely it's a good guideline when you're in the cloud of apps to kind of look at and what might be kind of things to steer towards. So in this lab, what are we going to do? We're going to go ahead and create a Node.js server. Spoiler alert, we did it in the last lab. We're going to create a Docker container image. Spoiler alert, we did it in the last lab. And then also we're going to create a container cluster, we're going to create a pod, and we're going to scale it up. By scaling it up, I mean that we're going to have one node, but say all of a sudden at midnight we have a spike of traffic and we need 3 servers to handle all that. We are going to go ahead and do that. So let's go ahead and get started. Start lab, launch with credits. Come on, do it. I'm going to go here and open console. Use another account. Log in. Copy the password. Next. And again, if I seem like I'm flying pretty fast here, don't worry. Again, you can run these labs in your own time. And just everyone to be clear, if you finish the GCP Essentials course, you will get an extra month free of Quick Labs, so which is fantastic. You can run these more on your own time. So we're going to go ahead and create a server with Cloud Shell. We'll launch the Cloud Shell as we did earlier. Start it. Hide this out. Whoa. Nope, this is not the lab. Hide this. Okay. So I'm in my shell. I'm going to vi server.js. I am now in Vim. Thank you, Quick Labs, for now telling me how to use Vim halfway through. This would have been helpful. So how to start the editor. You do I for insert mode. Copy the content. And save it with right quit. It's also there. You can run this with node server.js. And using a built-in thing for the Cloud Shell, you can actually get a web preview by just clicking preview port 8080. And you see, wow, that is way too tiny. Hello world, hey, how's it going? Good. That's not really exciting. It's just basically we created a server, all right? So let's Control-C out of that. We're going to create a Docker file again. We're going to copy this, basically saying from node, this version of node, expose port 8080, copy the server.js file into there, and run the command node server.js. Node being the command to execute and the file to execute the command against. Save it. We are going to do Docker build. CRL, $dev shell, project ID, boop. So right now what I'm doing is I'm actually building the container. It's very similar to what we did in the last lab. Let's go ahead and download the node library. It's getting everything set up, all the extra packages and stuff like that, the caching. Almost done. There we go. Docker run -d port 8080, expose port 8080 from port 8080. I'm going to now run it locally just to show that it's actually in a container. ID, hello node. All right, now if I do Docker PS, you'll see that the container's actually, sorry about that, the container's actually running. I can now go ahead and just do web preview. And once again, we see hello world because I'm running the same thing I did outside of a container in a container. Woohoo, fantastic. So that's great and all, but now we're going to actually docker docker stop 9e, the container ID. It's done. So we tested it. The code works. Let's go ahead and publish it. So dev shell project d hello node v1. What I'm doing now is I'm taking that image I just built locally and putting it in my registry so I can share it with the world, or whoever has access to the registry in this case. Just me. While that's getting pushed, if you go into the container registry, in the console, you see hello node. That was the container we built. That's the container I just published. It is now in the container registry, which means now we can actually go ahead and do the Kubernetes bit. So to get started, we're going to actually need to do a Kubernetes cluster. And the way to get this is within Google Cloud, there's actually a managed Kubernetes engine. So this means that all the beautiful operational duties are handled by Google. So let's clap for that. Because running your own Kubernetes cluster is not impossible, but to get a production-ready Kubernetes cluster definitely involves a lot of work. It is a paid service, but it's a pretty good service, I think. So you hit create cluster, and you can actually create it via the UI, but we're going to do it via the command line. So I'm just going to copy the command they gave me. If you wanted to, you could use UI. You just got to take the data and like hello world, etc. But I'm just going to do the command line because it's much easier to send that and just do the cluster. This is also documented here. So it's running. It's running version 1.10, which just came out yesterday, and I'm so happy the lab didn't break on me in between the 2 days. What it's actually doing is creating the cluster, so I'm wondering if it'll actually start appearing here. As you can see, it's provisioning in the back here now. This does take some time because what it's actually doing is it's spinning up all the infrastructure involved with Kubernetes. So we can see that here. Hopefully in a sec. Like the master, the zone nodes, the subnet allocation, the IP spacing, storage. This is the waiting game. And sorry again if I'm running a little bit fast. I did want to just at least show this for all y'all. So I did promise this. Apologies. After a little bit, you'll see it, and we'll have kubectl. So I guess while this is getting started, the concept of a pod is really a group of containers. So remember in the previous steps we had a bunch of containers. A pod is a bunch of containers tied together into one bundle, if you will, for like administrating it, rolling it out, and also for networking, allowing access to it and stuff. This could be one container, which is what we're going to do here, but you can also have multiple containers, which is a little bit advanced, but not that crazy to do. So it's not done yet. Come on. It's much faster yesterday. Must know that I'm doing a live demo. Hey, haha! I see all I had to do is call it out, and it started to work. Great. So we're going to actually go ahead and create our pod. So go copy the command. I'm going to say kubectl run the pod hello node from the image GCR, and that is not right. That's going to be wrong. So I say no project ID. Shoot. Yeah, that's what I thought. So I'm going to copy kubectl run hello node -- image equal gcr.io / $dev shell project _ ID hello node version 1 dash port 8080. And there's an equal sign there. I typed something wrong. What did I type wrong? Ah, see? I have run out of energy drinks, so my energy is slowly crashing, as I'm sure all of y'all. Don't worry, we're almost done here. So right now, I just created a deployment for Hello Node using the image, and it's going to use port 80. I'm going to just look at my deployments that I have created, kubectl get deployments, and I'm going to see that I have a deployment desired of 1, current 1, up to date 1, and available 0. Available meaning how many of this image is actually running. Right now it's 0, but if we do it in a few seconds, at last I saw 36 seconds. Is Joel going to be wrong? Hey, 34 seconds, beat me by 2 seconds. So this means that that container is actually, that deployment is actually up and running. We have one pod running here. So if I do kubectl get pods, we see that the pod hello node is running 1 of 1, and there's no restarts, nothing bad's happened to us, which is fantastic. We can do cluster info to see some information about the cluster. So you can see that the Kubernetes master. This is a lot of things here. Look at the documentation. There's a link there. Let's swing by the kubectl logs. Kubectl logs. The pod name is going to be hello. Oh gosh, I'm just going to copy that in giant name here. There's no real logs, but if there were logs there. So this is fine and fantastic, it's running, but nothing is really able to hit this container. So we want this container to be up and running so we can access it from the website, right? So what we're going to do is we're going to do kubectl expose the deployment hello node with a type load type equal load balancer. We're going to create a load balancer to expose this service. It just did it. So now if I do kubectl get services, we're going to see that the cluster IP is there. That's the internal. And right now it's just pending because it's going out and actually giving me a public IP. This takes about a minute or so in my experience. Let's try it again. Maybe I'm wrong. Nope, still not done. Seconds instead of a minute. Oh. Hey, there's a public IP. Beat me by 4 seconds. So now I can take that external IP and actually go another tab. Come on, Chrome. Oh, and it's port 8080. I forgot about that. Port 8080. And it says, hello world. Cool. We just got up a pod with 1 of 1, and it's now exposed on the internet at this random 35 whatever IP that Kubernetes spun back to me. So that's fantastic, but we only have 1 container running right now, and we want to make that 4. Let's say purchases are going through the roof, and you need to scale to handle more load. Great. So with kubectl scale the deployment called hello node dash replicas equal 4. Great. So now I just basically added 4 containers. So now if I do kubectl get deployment, you'll see that I have a desired of 4, 4, 4, but only 3 of which are available because I caught it before the 4th one was up. It takes about a few seconds for that one to come up. But if I do kubectl get pods, you see that I have 3 running, and 1 of them is being created because I just caught it in the creation process. But if I keep spamming it, hey, there it goes. It's starting to run. So now I have 4 like containers being load balanced evenly by that IP here. You can see hello world. Not the most amazing again, but we did cover a lot of concepts in that. So let's make a quick change to this server. So if we do server.js, and we're going to say hello GDG world. Not exactly what they wanted, but that's fine. It's my demo right now, so I'm going to do that. So I'm going to Docker build new image. Dev shell project ID. I created a new container for v2 because I made a v1 image. I am now going to push that container. Again, just copying this command. I'm going to edit this. $dev shell project ID. I'm actually going to take that image and push it. As you see, some of those layers already exist. I only push the diffs. That's the great advantage of using Docker. You can push the diffs out. This is for the demo purposes. This is great. There are much better ways of handling deployments within Kubernetes. This is certainly one way of doing it, but I definitely encourage how to deploy your service within Kubernetes, and this is a pretty raw way of doing so. They're basically going to do kubectl edit deployment hello node, and you're going to have a giant file, right? What we're interested in is in here somewhere, there is a spec containers image, and we're going to change that from v1 to v2, okay? And I'm going to save this file. Once I save this file, Kubernetes said, hey, wait a second, you just modified the deployment. So now you want me to use v2? Okay, fine, that's cool. But I need to now redeploy new containers. kubectl get deployments. You'll start seeing this weird current 5 because what it's actually doing is kubectl get pods. You'll see that now new containers are spinning up and the old containers are being terminated. Basically what just happened is I built a new image that responds hello GDG world, and those are now being booted up. The old images are getting torn down, and if we got this right, this should now, oh cache, please don't burn me today. Let's try an incognito window. Incognito is always fun. Oh, are all the services up? Oh, there's still one legacy one running. Darn. Should be up in a sec. Let me see if I get lucky and do a little bit of cache hackery. We'll come back to that. So it's going to take a few because what it's doing is doing it in a graceful state. It's already had 4, so it's going to tear down one, bring up another, tear down one, bring up another one. There is a Kubernetes graphical dashboard. I'm not going to do it in this lab for sake of time. I know that a lot of folks want to see it, but it essentially looks like this. You can see the CPU of your cluster. How much memory is my cluster using? We are running very small containers, so it's only about 34 meg, not that much. How many deployments is this Kubernetes master running? In our case, it's only going to be 1. What are the pods? How much memory? How much CPU per pod? You can see maybe one pod is all of a sudden pegged, and you can say, wait a second, why is that one pod all of a sudden taking traffic? Maybe debug it from there. There's various ways of attacking, various ways to connect to it. You can use the UI, but you can also use the command line. And that is a quick whirlwind tour of Kubernetes. And if this works, hey, there it goes. Hey, sweet. So it just responded hello GDG world because I'm assuming all the pods are the new one. And they are. Now we have only 4 pods of the new container. So yes, did I run through this lab very, very fast? Yes, and apologies. I just did want to kind of go through this lab relatively fast for the folks that I did promises for. Please, by all means, continue the journey through learning all this stuff. You have a month. If you complete that other lab, you have another month. If anyone ran into any issues getting set up, please reach out to me on Meetup or the email. We'll be more than happy to get everyone squared away with access to this so we can keep learning and building on this stuff. So thank you everyone for having and thank you everyone for coming out. Any questions, go by and swing up there. Yeah, what's up? Yeah, of course. Here you go.
Oh, thank you. So I can connect with you.
Yeah, of course. Anytime, and also if anything on Meetup, anything you want to talk about, I'm always on there. Woo. Yeah, so feel free to reach out. Hey.
You know, I was talking that persistency on disk.
Yeah.
Now, well, make sure I want to make sure I understand this. You make it persistent in the region.
Yes.
Is it building that disk in multiple availability zones?
No, it's just
Only
one.
one.
Just one. That's important to know. That's why I was saying that
Yeah.
you want that image, or sorry, that disk to be in the same zone as your server that you're going to be using it on.
Same zone.
Yeah. There are certainly ways around it with NFS or like a Samba, but that's kind of the way.
So when you built that server, you only built it in the zone. I mean, in the region.
In the region, I maybe I typed too fast, but I actually did -C.
One day, okay.
Yeah,
one
yeah,
C
yeah.
is the availability zone. Okay.
Does the quick labs entitlement happen automatically?
I'm sorry.
Does the quick labs entitlement happen automatically?
The way you can verify it is if you go to the top and you like click. Oh, sorry. Buy credits.
Okay.
Instead of buy credits, you'll see like you have like Premier access, and it'll say it'll expire April 28th.
Okay.
If you complete the GCP Essentials, you'll get another month on top of that.
Okay.
Yeah.
Thank you. That was my question.
No worries.
I had a question regarding the pods and the containers.
Yes.
So can there can ever be a case where the same container is running twice on the pod, on the same pod?
If
I'm
you-
not spinning up one more pod for the same container. I'm running two containers which are same.
Same
on the
image.
Same pod. Same image on the same pod.
Yes, you can run multiple containers on there.
Right.
You will have to be careful because port how you expose
Right.
it, right?
So
The port.
I'm giving the different ports for
Yeah,
both the containers.
you definitely
But,
could.
Okay, we can do that.
Yeah.
And what would be the use case where we can do that? Do you ever come across such a use case where I'm going to be suppose I
Maybe
have
if
two
you want to
microservices.
balance load, but
Right.
I definitely would recommend
So like I
sticking
have a
to load
microservice,
balancer.
I have a microservice running, and I don't want to spin up a new pod for it.
Yeah.
I want to use the same pod because I'm less in the resources.
Yeah, of course.
So we can do that, right?
You should be able to, yes, spin that up. The
That's
thing
not
is,
the ideal situation. I
yeah,
understand.
you definitely want to scale your service, your pod to be kind of a one-off container of what is needed to run that app. So you may have like a front end and a back end. That's the most common way I've seen it, like
Right.
a UI and a Java app in the back.
Right.
You can do that.
Right.
And one runs
It's
on
like different
8080.
different kind of services running on the same pod. And
Yeah,
the
because
same
then when you
things running
scale
on
it, you
another
saw
pod.
when I scaled it,
Right.
it'll scale that same way.
Horizontally, right.
Yeah, so that you kind of have a nice horizontal scale. Very easy. Yeah.
All right, thanks.
Cool.
That was
No
great.
worries. Thanks. Hello.
I'm sorry, I got here late.
Yes.
Can I still
Get the free stuff?
Yeah, either get the labs or whatever.
Yeah.
I
So
was listening, or I noticed that was being YouTube or whatever.
yeah. So
and
I'm
I was trying
recording
to-
it.
I was trying to watch that.
Don't worry about it. The YouTube will be available. The way to get started is make sure you create an account if you haven't already. There's gonna be like an opt-in box, like, hey, do you want to get emails from Quick Labs? Yes. The reason why is after you complete the labs, Google will actually give you another month for free to do the labs.
Okay.
So you create an account, right? Once you have created the account, go to this link, and you're gonna see something like enroll in this course.
Okay.
So click and enroll in this course, and it'll give you the lab. So when you go to launch a lab, like you go to create a virtual machine,
Yeah.
it'll say launch using your subscription.
Okay.
Yeah. So that's the way to get started. Now, a thing to note, I guess I should be clear, that link will expire tonight at midnight. So try
I
and,
need to do it tonight.
Yeah.
you're saying.
yeah.
Oh.
If you have your laptop, I can help you guide you.
Yeah.
Yeah.
I
So
can do it
yeah,
here.
yeah. Go ahead and get started. Go to the meetup and follow that link. At least create an account, and I'll
great.
meet you up. What's up?
So do you are there any open source projects where I can implement Docker and Kubernetes and learn more about it?
I personally don't, but Docker celebrated its 5th birthday. So if you type in Docker 5th birthday on GitHub, you'll actually see this Docker 5th birthday examples, and there's actually quite a bit of free code labs you can run on your local machine, even with Kubernetes, because with Docker for Mac, the latest version that actually supposedly came out today, Kubernetes is actually built into that, so you can run all this locally, which is fantastic. So it'll actually show you how to do like Docker for Mac and getting it running and these commands and deploy a voting app and everything.
Sounds good.
Yeah, so Docker 5th birthday and GitHub. Yeah.
Thanks.
Yeah, no worries.
That was
Hey, thanks. What do you think?
awesome.
Yeah, I'm gonna go up 62. Yeah.
Thank you so much.
Yeah, no worries. You enjoy it?
Yeah, I like this.
So yeah, sorry I ran through a little bit fast at the end, but I did. Like I said, are we gonna cover Kubernetes? I'm like, I'll try. So that was like 5-10 minutes.
So
Yeah.
can I get your card and this
Yeah.
thing? Like the Wi-Fi she was talking about?
Yeah. This is like my job card, but you can find me on Meetup and get more. Like,
Sure.
yeah.
And the lady was talking about something about the Wi-Fi. Is that
Oh, you don't have one? Yeah,
No.
take one.
okay?
Yeah.
Perfect.
So when you fly, you can.
Anytime.
Yeah, it's a pretty cool one.
Where are those?
So if you fly often, this is a pretty cool because it's a free code to use our service.
Oh,
So you don't have to pay like $40 or whatever it may be.
Nice.
Yeah.
Just for someone who's getting
Thank you so much.
started with Linux, where do you recommend starting off? Because I mean, all these commands are kind of just a lot at one time.
No, I agree, and I was trying to explain as much because I noticed a lot of folks that I talked to.
I have a good amount. Like I understand
yeah.
most of it, and like I've used it before. But I just, given that you're a Linux admin, it just probably makes sense to ask someone who. Good job. Gone
Thank
through
you. I would recommend. You know what? It's funny, but I use Reddit a lot.
Really? Okay.
Yeah. So there's a lot of subreddits for like Linux.
Just
or,
okay.
Yeah, you can see that. Intro to Linux. The best way is honestly create an image and play around.
Okay.
Some I don't know if Quick Labs actually does Quick Labs have.
It's a freaking man.
Yeah, I mean, don't get me wrong. Like I've definitely had my fair share of like messing around with things, and things break, and then I have
I had like a 10 gigabyte hard drive, and it keeps telling me I'm out of room.
Yeah, it's GoGo Wi-Fi exclamation point, all lowercase. GoGo Wi-Fi exclamation point.
Were we supposed to fill out something, a survey or something?
Yeah, I don't know if we can. Yeah, I blew through this. We'll probably send an exit survey like, hey, everybody submit it, and we'll figure it out from there. Actually, you know what? Yeah, how can I forget this? Linux Foundation has some great ways of getting started.
Linux Foundation?
Yeah, Linux Foundation is great. There's like Introduction to Linux. There's things like playing around with it enough, you'll kind of start getting it. Udemy has free stuff too.
Gotcha. Yeah, I figured there's some course.
So what is the deal with that no space on the roof? Why doesn't it just use some of the rest of the hard drive?
What do you mean? The 5 gig?
I keep getting. I have a Linux thing
system.
I try to set up on a virtual machine.
Yeah.
And it's like 10 gig on the hard drive, but
Yeah.
it keeps telling me I'm out of space on the roof.
So maybe it's filled up. They give you like
But
download.
there's like 7 gig of space left on the hard drive. Is it only just using one partition or something?
You could be in a different partition. So like as you saw, I mounted like /mount my disk. That was 200 gig, right? But like, the rest was 5 gig.
Does it decide on its own to make a smaller partition, or when you install
Should
it?
not. When you're installing Linux for the first time, you can definitely repartition it to be smaller or larger. So maybe that's the way of checking. Yeah. Definitely for sure. That sounds like yeah.
Can I just grab your card?
Yeah, sure.
Thank you very much. I really appreciate it. You did
No
a
worries.
great job, and you did a lot of talking.
Yeah.
A lot of talking.
Yeah.
Appreciate it.
Thanks for coming, and we'd like to see you more at the next event. So who's going by? Hey, what up?
I just moved here from Denver.
Ooh, fancy. Nice. I like
this is
Denver.
one of my first meetups in Chicago.
Cool. Yeah, there's a bunch. Chicago has a great scene for Java, JavaScript. It's fantastic.
Sweet. Yeah, I'm psyched to hear about that. How often is the GDG meetup?
We aim for once a month. We are investigating. Not investigating. We're trying to really get involved with women tech makers more. So we may do bi-monthly, like 2 months. Yeah.
Okay.
So we'll figure out how that works. But
Cool.
yeah, with Dina, she's their new GDG lead. So we're gonna. I don't see her.
They had a really good turnout.
Yeah.
The GDG number is like 20 people. It's kind of intimate and more like a.
Yeah, we had a big crowd, and I'm happy for the end. Like all said and done, it ended up working pretty well. So
That's awesome.
yeah, but we would love to have you sign up on our Meetup page, follow us on Twitter. In fact, every year we have a Dev Fest where we have like 26 speakers. It's a conference.
Whose conference is it?
Huh? Shut up.
Whose conference is it?
We run it. We
We as
GDG.
in who?
GDG.
GDG?
Yeah, so we
You know
we get
Google
fun.
I/O?
Yeah, Google I/O, huh?
Is that in Chicago too?
No, that's in California, but we do an extended event for the folks that can't make it. So we bring back the knowledge and share with the community.
We had an I/O conference in Denver.
Oh, really?
Yeah, so I'm surprised you don't have it in Chicago.
We like IO extended? Is it IO extended?
Yeah.
No, we are gonna have one. We're just waiting. We're gonna wait to run it after the event. So we're gonna run. We just haven't published it on Meetup yet.
Oh, sweet.
Yeah.
So it hasn't happened this year yet?
No, not yet. It's
You guys-
happening in May.
Oh yeah, you need volunteers or anything?
We are trying to figure out what we're gonna do. The May is so far away. Like my brain was just on this meetup, but
What
I
are we
think
trying to figure out?
IO extended this May 15th.
Yeah, May 15th.
Hey Dan.
Hello,
I'm Wes.
Dan. Obviously.
Hey,
Look like
What
your
up?
picture on
is
Meetup.
Kubernetes
Yeah.
production ready right
Yes.
now? Can it be used?
Yes, in fact, it's probably one of the most production-ready services. Docker is definitely leveraging it as go ahead. As one of its
Because
Docker. So you're probably hearing like Docker Swarm and Kubernetes, right? Kubernetes is a graduated app of CNCF, which is a huge deal. It's the first one, which means essentially it is no longer maintained by them, but it's maintained by a community, which is huge. I know.
But I've heard in my company that Kubernetes right now is not production ready because it has some firewall. I'm not very sure about it. That so I work for Walgreens.
Okay.
Walgreens is trying to integrate Kubernetes already for our dev and QA
Good.
servers. Because since there's no firewall that
Blocking you.
blocking us or anything. But in production, we are not able to do it because the solution architect is like, there's a firewall problem. I'm not really sure why he said that.
That's odd. No, I don't know really much of anything. There's no
Are there
major
any
issues.
Other companies which are already
Use Kubernetes?
using Kubernetes?
Oh yeah,
in production?
Netflix, Amazon. Amazon's actually releasing a service for it. There's open source things from. I mean, we're looking at it here at GoGo. We don't have it fully in production yet, but we're actively looking towards it.
Okay. See, already in GoGo, you guys
Under
already
Armour uses
implemented-
it. Under Armour, the company. Yeah, it's big. And
So in GoGo, you're already you're through with QA, dev QA, all that. You're already using Kubernetes for it.
yeah, right now. In fact, the software is based on Google's board. It was essentially like the open source version of what they have.
So my primary purpose of coming here was to understand whether I can leverage Spark with Kubernetes.
Ooh.
Right. So I'm using Apache Spark for my computation as a computation engine for in-memory computation. And since